Okay, so Shun asked how we would kind of manipulate the population growth formula in order to calculate things like R or to estimate population growth rates over time. And so you're going to have a chance to calculate are for some of the duckweed populations that you're examining in this week's lab. But I wanted to show you guys, at Shun's request, a practice problem that may help to illustrate how you can manipulate these numbers. So this problem states that in your research on population dynamics of June beetles, you estimate that the population size is 300. So we need to remember that in population ecology, the size of the population is represented by uppercase N. So our size is 300. Or I'm sorry, 3,000. Then it says over the course of a month, you record 400 births and 150 deaths in the population. So those are denoted with B's and D's. So births equals 400, deaths equals 150. So the difference between B and D equals 250 in this case. And that's a positive difference. That's going to be growth because the births is the higher number. So what we know at this point is that the change in N over the change in T, or the change in time, over this interval was equal to 250 individuals, and it was a positive change. 250 individuals were added to the population. So we walked through the population growth formula, and I showed you guys that R is the per capita rate of increase. So this 250 is not per capita. The 250 is the total number of individuals that were added to the population. So to make it per capita, all we need to do is divide it by 3,000, or the number of individuals in the population. So R, and it should be lowercase, it keeps adjusting these. Oh, good, it didn't. So R is going to equal 250 divided by 3,000, which equals 0.083. And then we can check our math if we want to. We know that the population growth formula that we looked at was change in N divided by change in N divided by change in T being equal to R times N. And so this N is the number of individuals in the population at the beginning of this interval before any change happened. So we can check our math here because we know that the change in the number of individuals over this interval was 250. So 250 does equal 0.083 times 3,000, which was the number of individuals in the population before this change took place. So you guys are going to manipulate numbers like these in your Lemna population growth lab. Hopefully you guys are able to do that. If you can't, make sure you let me know and I can give you some guidance on that. Okay, that's it. See ya.